This video is on the oxidation of alcohols. And our aims for this video are to be able to identify primary, secondary and tertiary alcohols, know the products of the oxidation of primary, secondary and tertiary alcohol, so different types of alcohol will give different products when you oxidise them, and know how to test for aldehydes as well. So first let me explain what an alcohol actually is. An alcohol is a molecule where the functional group is an OH group. So this is an alcohol, this is propanol, because it's got 3 carbons. If you're unsure on how to name alcohols, then please watch the nomenclature video. And this one here is a primary alcohol, and the reason it's a primary alcohol is because it's got 2 H groups on it, on the carbon that the OH is attached to. And so this means that this can be oxidised further twice, because the CH bonds are the ones that are broken during oxidation, the CC bonds aren't, because the CH bonds are weaker than the CC bonds. So this one here is a primary alcohol, due to the fact that it's got 2 H's on the group that the OH group is attached to. A secondary alcohol is an alcohol where you've only got 1 H attached to the carbon that the OH group is attached to. So for example, you might have the following alcohol. So this one would be called propan-2-ol, because the OH group is on the second carbon in the carbon chain. There are 3 in the carbon chain. And this one here would be a secondary alcohol, because you only have 1 hydrogen attached to this C that the OH is attached to. Finally, you could get tertiary alcohols, and those alcohols are alcohols where you've got no H attached to where the OH is attached to, the carbon is attached to. So a tertiary alcohol would be the following. So you've got OH and then CH3s all around the C where the OH is attached to. And this cannot be oxidised because there are no CH bonds to break on the C attached to the OH. So this one would be called 2-methyl-propan-2-ol, and this is an example of a tertiary alcohol, as I said, because there are no hydrogens on the carbon which the OH group is attached to. So primary alcohol has 2 hydrogens attached to the carbon that the OH is attached to. A secondary alcohol only has 1 hydrogen attached to the carbon the OH group is attached to, and tertiary alcohols have no hydrogens attached to the carbon that the OH is attached to. So as I said, these different alcohols will oxidise in different ways, depending on what the type of alcohol it is. So if you have a primary alcohol, so as I said before, that's an alcohol where the carbon that the OH is attached to has 2 hydrogens attached to it. If you were to oxidise this using, for example, potassium dichromate, that's what you could use, you can oxidise this twice. The first time you oxidise it, you will make an aldehyde, and an aldehyde has the following functional group. It's C, double bond O, and an H attached to it as well. This R group just shows that this could be anything on this side. And then, if you leave the aldehyde with the potassium dichromate, that will oxidise further to a carboxylic acid, which has the functional group C, double bond O, OH. So the first time it gets oxidised, which you can use a symbol of this symbol here, an O in square brackets, that will create the aldehyde, and the second time you will create the carboxylic acid. If you just want to make the aldehyde, then you have to make sure you distill off this product once you make it. But if you want to make the carboxylic acid, you have to put the reaction under reflux. And what that means is that whatever is made from the reaction condenses back down into the reaction vessel to make sure it reacts again. So the aldehyde will be made, or will evaporate off because it's quite volatile, and then it'll condense again in a reflux tube, and that will drip back down into the reaction vessel, and then the carboxylic will be made. by the oxidation of the aldehyde by potassium dichromate. If you have a secondary alcohol, then you only have one CH bond to break, and so this can only be oxidized once, and what that will make is a ketone, and what a ketone has is a C-double bond, but on either side there are R groups. A tertiary alcohol does not oxidize because the CC bonds are too strong to break. There are no CH bonds attached to no H is attached to the carbon the OH group is attached to, and so there's no bonds that can be broken by via oxidation. So tertiary alcohols do not react. Secondary alcohols only oxidize once and they form ketones, and then primary alcohols will oxidize twice. In the first instance will make an aldehyde, and then once oxidized again you'll make a carboxylic acid. As I said, potassium dichromate can be used to do these oxidations. So how will you know what products you've got? So you've got to be able to test for these different products, and there's a specific way you can test for aldehydes, and it's based on the fact that an aldehyde can be oxidized further. You've got to use a reagent that will oxidize the aldehyde and therefore give you a positive test for that. And usually what a question asks you is how you can test for an aldehyde, between the difference between an aldehyde and a ketone. And what you can use is either Tollens reagent, or you can use Fehling solution. And these two things will do different things depending on whether you've got an aldehyde or a ketone. So an aldehyde will give a silver mirror with Tollens reagent, but a ketone, and indeed a carboxylic acid, will do nothing, so you'll see no visible change. With Fehling solution, you'll see a brick red precipitate. I'm going to use the abbreviation PPT here, which you can do in an exam if you wish. You must say brick red precipitate. You've got to use this word or this abbreviation precipitate to explain what you're actually seeing. Either you see a solution or you see a precipitate. You've got to be specific. So for Fehling solution with an aldehyde, you see a brick red precipitate, and you see no visible change for a ketone and, again, a carboxylic acid if they ask you that question. So let's have a look at a couple of past exam questions. So firstly, butan-2-ol can be oxidized by acidified potassium dichromate to form butanone, as shown by the following equation. There it is. State the class of alcohol to which butan-2-ol belongs. Well, there's two ways you can figure this out. Firstly, you can see that butanone is made, so a ketone is made, and there's only one class of alcohols that forms a ketone via oxidation, and that is the secondary alcohols. The other way you can work it out is by drawing out butan-2-ol. So this is butan-2-ol. You've got the OH group on the second carbon along. Everything else are H's. And you can see that the carbon that the OH group is attached to only has one H attached to it. The other two bonds are to carbons. And so this must be a secondary alcohol. So the class of alcohols is secondary alcohols. This next question is a tests question. So a chemical test can be used to distinguish between separate samples of isomer 2 and isomer 3. So there's isomer 2, there's isomer 3. Identify a suitable reagent for the test, state what you'd observe with isomer 2 and the isomer 3. So first you've got to figure out what these compounds are. Now you can see this has a C-double bond O H group. So this is an aldehyde. And this isomer 3 has a CO group, C-double bond O, but either side is flanked by just carbons. So this is a ketone. So as I said before, there is two things you could use to test for these. Either you can use Tollens reagent, or you can use Fehling solution. And for Tollens, you will see with the aldehyde, isomer 2, a silver mirror. And for isomer 3, the ketone, you'll see no visible change. And for failing solution, if you were to choose that as your test reagent, then you get a brick red precipitate for the aldehyde, and again you'd see no visible change for the ketone. You can choose either of those two things to start with. You don't have to put them both, but if you choose Tollens, you've got to go with silver mirror, and if you go with failing solution, you've got to go with brick red precipitate. Obviously, you can't mix and match the two answers. Hope that helps. Please let me know if you need any more help.